So the first question we want to ask is, why study chemistry? For most of you, chemistry is not your major. But chemistry is part of the world around us, no matter where we look. The technology that's rapidly expanding is expanding at such a rapid rate, mainly due to the advances in chemistry research. So if you look at the title of our book, it's called Chemistry, the Central Science. So one of the reasons we want to study chemistry is because it is the central science. And any type of science major, whether you be biology, whether you're going into engineering, whether you're going into medicine, you're going to use chemistry. And it is the pinnacle and the overlapping point and the overlapping discipline in all of our science curriculum. So we need a good foundation and good fundamentals of chemistry in order to succeed in any discipline. Another reason we want to study chemistry is because it's going to give you a tool that you need to succeed in any aspect of life, and that is non-routine problem-solving skills. You're going to be faced with many problems in this class. They're not going to be easy to figure out. And we can give you a template of how to solve those problems, but the real science and the real chemistry comes when you don't know how to solve a problem, or you don't know the answer to a particular problem, but you can use what you have to figure that out. So before we go on to get into the meat and potatoes of this course, we need to ask ourselves, what is chemistry? And our textbook simply defines chemistry as the study of the properties and behavior of matter. And we can also define matter as anything that takes up space and has a mass. So we're not really limiting ourselves by saying that chemistry is the study of the properties and the behavior of anything that has a mass and takes up space. So when we go and talk about matter, we can say, and most of this will be a review for everyone, that the three states of matter are a solid, which has a definite shape and a definite volume, a liquid has an indefinite shape and a definite volume, while a gas has an indefinite shape and an indefinite volume. Most of you are well aware of these facts, but the key thing that we want to know is, how do we as chemists, manipulate the properties of solids, liquids, and gases. So if we look at these three states of matter, we have a solid up here. I'm going to represent liquids down here in the bottom left and gases over here to the right. How do we look at the properties? And if we go from a liquid to a solid, we call that freezing. When we go from a solid to a liquid, we'll refer to this as melting. We need to know the language and how we characterize each of these things. And we're going to talk about how we can manipulate the properties of this freezing. Does everything have the same freezing temperature? If I want something to freeze at a lower temperature or a higher temperature, how would I do that? How can I melt something that's a solid? When would it be practical to do so? If we look at the properties of a liquid and a gas, if we go from a liquid to a gas, we refer to that as evaporation. And if we go from a gas over to a liquid, that is condensation. If we go from a solid to a gas, that's referred to as sublimation. And if we go from a gas to a solid, we refer to this as deposition. So we are interested in the reactions and the properties and how we are going to measure the various states and properties of matter. So this little figure down here is going to kind of provide a template for all the tools and give such a broad representation of what we are going to be studying in this course. So we'll pick up next with the various properties of matter.